All right, so here's the assignment. Important things probably to highlight first of all are the due dates. So you are being given it today. Okay, so there's this monitoring date a week out. So I won't be here for the monitoring date, but Miss Baldwin will, and she'll try to give you some feedback by Tuesday's lesson. Okay, just some basic things. So if you can complete the assignment before then, she'll just have a quick look over it, maybe give you one or two hints. She's not going to go through it in like super detail, but just to give you some sort of insight. In terms of where that monitoring should be, okay, it should be on the OneNote. Okay, so just like we tried to do last time, put it in your individual folder, okay, so that at any time we can check how you're going and where you're at. So for example, if you're carried, maybe just put it in homework here and just make it obvious where it is. Yep, so everyone just put theirs in homework and we'll go from there. Due date, 17th of August, so if you don't hand anything in on the due date, we'll just accept whatever we get on the monitoring date. Okay, so any questions? Any questions, internet people? No? Too bad. Okay, so you'll get marks for communication, modeling, and knowledge, just like always. And you got to sign here to say that you haven't copied off someone. All right, so I'll mark according to this grid, okay, just like for the last assignment. So give you just an overall grade. All right, so the background here you can probably just read for yourself. Just talking about the greenhouse effect and the temperatures increasing over time. Okay, so we've got some data. Okay, so as soon as I see that data, I think I'm going to make some sort of graph, temperature versus the year. What's going on? So just for consistency, make these n's little t's, okay, and that'll be consistent with the questions. So I changed all the n's to the t's, but I must have just missed those two. Okay, so I see this data. I think I'm going to graph the temperature over time. Okay, see what it looks like. I'm not sure what it looks like. See what sort of relationship it is. Is it linear, exponential? Who knows? That's the overall assignment. Okay, to look at this data and determine what sort of relationship it is, and then see if you can use that relationship to predict into the future. Any questions? Right. So does that make sense? So how do you think we're going to analyze this data? We're going to just do it by hand on a piece of paper? Yep, very good, Dean. Put it in Desmos. Good contribution. Okay, so put it in Desmos and run those regressions like you did for the previous assignment. Okay, so in all these questions, okay, you'd be expected to put like a screenshot of your Desmos graph in there. Okay, so that you can justify how you got that. Okay, so you enter your data in, do your regression, and show it. Okay, definitely comment on the R-squared values. So what do we know about R-squared values? What's a good R-squared value? Yeah, one would be the best one. Okay, what would we accept as good R-squared value? So just to remind you of that. Okay, so it's a measure of how well the line of best fit fits the data. So you'll see in this one, it's just sort of randomly through the data. It doesn't really show any relationship at all. But in this one, the line perfectly fits the data. So we get R-squared value of 1. Okay, so if I get an R-squared value of greater than 0.9, I'm pretty happy with that model. I'm satisfied that it's a reasonable way of describing that variation in data. Okay, so there's a Term 2 assignment resources tab in the OneNote you can go through just in case you're unsure about R-squared values. Maybe do a bit of research. I'm sure there's heaps of YouTube videos around about that topic. So yeah, always just define your variables as well. So make sure you're saying, even though it tells you in the question what t and little t is, make sure you're defining the variables just for the communication. And yeah, state your assumptions, state whether it's reasonable. So is it reasonable for the Earth's temperature to be 1,000 degrees Celsius more than it was in 1860? Sorry, question? Yeah. Yep, yeah. So the question was, do you want us to comment on the exponential regression as well? Yep, so in your assignment, you should have a linear regression from Excel and then a exponential regression on Excel, and you'll comment on both of them. So you get an R-squared value here, you'll be able to look at this one. Get an R-squared value here, be able to look at this one as well. Okay, so this sort of underlined sentence should really appear in the question below as well. Okay, it's all getting a bit messy, but that's all right. Okay, and then once you're happy with your model, you'll use some predictions. Use it to make some predictions. Yeah. Okay, and always looking for ways to check our answers. So maybe you substitute for F, maybe you substitute it into the formula, and then maybe you can verify it by just showing on the graph that you get the same answer. Okay, to justify your solution. Okay, if you've got time. You don't have to do that for everyone. Just make sure you do it sort of like once or twice around the whole assignment. Okay, so that's using Desmos. Okay, question 2 is doing it all algebraically. Okay, so in question 2, you don't have a whole heap of data. You've just got 2 pieces of data. Okay, and from those 2 pieces of data, you should be able to find the same model. That should be a T as well. Yeah, my mistake again. Okay, so using values from the above table, find the values of the constants A and K. So basically find the model just using those 2 values. There's a video there you can watch that might give you some advice on how you can do that. Okay, so I'm not going to help you out with it. You can research around yourself, find different ways of finding that that model. So yeah, use that to do the same predictions. Okay, any assumptions you made, reasonableness, and you'll be able to compare. So question B and C is really the same question as question F and G. Okay, so you're comparing those 2. Okay, to see which scientist will give you a better answer, a more reliable answer in terms of what the temperature will be in 2060. Because that's important, right? You're wondering, what's life going to be like when I'm 35? Okay, so you're predicting for when you're my age. Question?
So G is supposed to be 8 degrees.
Yeah, so that's a formatting error. 8 degrees, yeah. Okay, that'll just be some word problem. Thank you again, Dean, for that contribution. The previous question was from Hannah, by the way, just to attribute things correctly. All right, so that's pretty much the first question. So if you're just hoping to get like a C, maybe like B minus, you can just do those first 2 questions. Okay, you don't have to have a go at the last question, but you'd be crazy not to, given that there's basically free marks on offer. All right, so the final question is about a logarithmic model. So it's sort of an application of logs, trying to explain to you why you might use logs in reality. And most common example you'll find in textbooks is the Richter scale. So you might want to do a bit of reading about the Richter scale before you even try this problem, just so that you understand sort of what it's about. So you've got a whole table of data. Okay, instantly when you look at this energy data, what do you notice about it? Yep. Yeah, they're all different units. So in general, we measure energy in joules, okay, using the letter J. So what does this K, what does kg stand for? Kj stand for? Yep. Kilojoules. Okay, so you'll have to look up what kilo means. Okay, I'll give you this one for free. It means times 10 to the power 3. You'll have to look at what mega, giga, tera, penta, exa mean. If I've got any of those wrong, I'll edit this video in the future so it looks like I had them all right. Okay, but you'll have to look at those. They progressively get bigger. So the smallest one is just a little hand grenade. So little explosion, all these ball bearings going everywhere. to these like massive earthquakes that are happening, nuclear bombs. So intensity getting bigger as you go down, and you can see the Richter scale accommodating that. Okay, so pretty much same as the previous question. You'll make some graph of energy and Richter scale, and who knows what the data looks like. You'll have to do that. See if you can find a model to fit it. See if you can find a relationship between the Richter scale and the energy released in the event. Okay, and then from there, there's some other questions that I'd expect if you're a B or A level student, you should be able to explore yourself without too much explanation. Any questions? No? Okay, so that's all. Obviously, it's tutoring Tuesday afternoons. You guys now have 25 minutes to work on your assignments. Okay, if you're out, playing sports or doing knitting or whatever it is, you can make up that time in your own time, which is at home, 25 minutes working your assignment.